The goals of every aerospace and defense organization are to win new business and to deliver consistent program execution excellence. A model-based enterprise gives organizations situational awareness that enables program execution excellence. As we compare an earlier set of program requirements with a current set, notice the changes are easily visible. In the verification planning process, the verification activity is initiated by defining the verification methods for each requirement. As the design of the project evolves from system architecture to preliminary design to the detailed design, requirements also need to be allocated to systems, assemblies, and components to ensure that each requirement is traceable to a specific product structure node. The product EBOM allocation report in the dashboard provides the real-time status of that traceability. The design engineer creates the EBOM definition of the test article using a specific production EBOM configuration. After receiving the test request and accepting ownership of the test article EBOM, the test engineer searches in the classification application for the instruments that match the specifications that are identified in the measurement requirements. In this case, 3 accelerometers match the frequency of 3000 Hz. The winglet assembly gets revised and the original rib is replaced with a new rib containing holes to accommodate accelerometers. After receiving the test procedure and the test article EBOM configuration, the test operator prepares the test article for execution of the test. In this case, the as-built structure is generated for the first configuration of the test article EBOM. It is shown here as Unit 1. Existing serialized accelerometers in DevCo Model 7268C are searched and their respective calibration dates are checked to be sure they're still valid. The serialized accelerometers with valid calibration dates are then installed at the 3 positions in the as-built structure. After the ITRR approval, the test operator has all of the approval data, including the test procedure, the test article configuration with instruments, the associated channel numbers, and other data required to execute the test. During the test execution, the raw data is recorded from all of the measuring instruments. The calibration information for each instrument is used to generate the processed data from the raw data. Next, data trace links between the raw data and processed output with test event are created. After the conclusion of all the analysis and test activities for verification of the flutter requirements, and during the verification process, the verification planner gets all test and analysis reports as well as all relevant data that has been generated. Since all relevant data was linked to the verification object throughout the process, it is easy for the verification planner to examine and review all the results and create a compliance report for the product requirements. Siemens enables program execution excellence through a verification management process that starts from the initial allocation of requirements through either test or analysis requirement verification with complete traceability of all the artifacts. This capability enables change management of requirements or product design throughout the life of a program, with complete situational awareness of the impact of a potential change prior to approval, by providing a robust, disciplined process that maximizes the reuse of both data and process. Siemens helps you ensure consistent program execution excellence.